Here we're going to be dealing with, in this session, how to solve polynomial equations by graphing. Over here at the right, what we have here is the function, the graph of the function for y equals x squared. And what I've done is I've gone ahead and placed on several different points that are solutions to this function, or that are points for this function. What I can do then is I can go ahead and connect these with a curve, knowing that that curve does continue indefinitely upwards on the graph forever. That, therefore, then is the graph of y equals x squared. But when we talk about what are the solutions to the equation that is x squared equaling to 0, because remember what we talked about before is an equation in one variable in standard form has all of the monomials on one side of the equation in descending order, and then on the other side is a 0. So taking a look at the equation x squared equals 0, how many different solutions are there to that? Well, there's just one, when x equals 0. But if we were to take a look at the function y equals x squared, we could actually come to the same conclusion. And the manner in which we do that is we take a look at the graph of the function y equals x squared, and we determine at which points does that graph intersect the x-axis. Well, in this particular graph here, it intersects it at the origin. It only intersects it one time. Since it only intersects the axis, the x-axis, one time, there's only one solution to the equation of that particular function. The equation removing the y and inserting a 0 in its place. Another way of thinking of it is that when y equals 0, how many solutions are there? And in this case, there's just one, when x equals 0. Let's come over here on our second screen. This y equals 2x squared minus 4x plus 4. This function is the one that we took a look at on a previous session. And I've gone ahead here and I've regraphed it right over here at the right. The question here is, when y is 0, how many solutions are there? How many values of x are there that will work, that will produce an equation that calculates out so that it equals 0? We're using what we said on our previous screen. The number of solutions that there will be the number of points at which this particular graph intersects the x-axis. Well, here's our x-axis here going horizontally, our y-axis going vertically up and down. How many points on this graph actually intersect or cross the x-axis? 0 do. What that tells us then is if we were to set this function equal to 0, y equal to 0, there would not be any values for x that would work, that would then calculate it out so that the right-hand side of the equation would equal 0. And it's beyond the scope of the lesson at this point, but in a few more sessions we're going to find out how to complete the square. And if we were to complete the square here in this quadratic, we would find out the reason why this particular formula, this particular function equation setting equal to 0 would not have any solutions is because in order for it to have a solution, there would have to be a square root of a negative number. And in this situation, in this point in algebra, we have not dealt with imaginary numbers being the square roots of negative numbers. And since the square root of negative numbers for our purposes do not yet exist or don't exist, this graph therefore indicates to us we have no solutions to this function where y equals 0. On the previous screen, we saw that there was one point at which it intersected. This graph, it intersects it 0 times. Well, let's take a look at another function here, x squared minus 2x minus 3. Let's go ahead and calculate out or make a table here. For my x values, I want minus 2, minus 1, 0. And for the positives, let's just take a look at 1, 2, 3, and 4. So these are going to be all our x values in our table. And then beneath it are going to go the y values. When x is minus 2, what's y? Well, minus 2 squared is 4. Minus 2 times minus 2 is also 4. 4 plus 4 is 8. 8 minus 3 is 5. How about when x is minus 1? Minus 1 squared is 1. Minus 2 times minus 1 is 2. 1 plus 2 is 3. 3 minus 3 is 0. How about when x is 0? 0 squared is 0. Negative 2 times 0 is 0. 0 plus 0, or excuse me, 0 minus 0 is 0. 0 minus 3 is a negative 3. How about when x is 1? 1 squared is 1. 2 times 1 is 2. 1 minus 2 is negative 1. Negative 1 minus 3 is negative 4. How about when x is 2? 2 squared is 4. 2 times 2 is negative, 2 times 2 is 4. 4 minus that 4 is 0. 0 minus 3 is minus 3. When x is 3, 3 squared is 9. 3 times 2 is 6. 9 minus 6 is 3. 3 minus 3 is 0. And then for 4, 4 squared is 16. 2 times 4 is 8. 16 minus 8 is 8. 8 minus 3 is 5. So let's go ahead over here now and plot these points. Minus 2, 5, right here. Minus 1, 0. 0 minus 3 is right there. 1 minus 4 there. 2 minus 3 comes to this point. 3 comma 0 here. And 4, 5 up here. So if I were to connect these with a smooth line and take that up, realizing it continues on upwards indefinitely, the question here is, how many places on the x-axis does this graph intersect? Well, it intersects at 2 places, at minus 1 and at plus 3. Minus 1 and plus 3. So if we were to take these two values and plug them right back in here, which is what we've already done in our table back down here, we'll see that our y value is 0. So the two solutions to this problem, to this equation, the equation being 2x to the second minus 4x plus 4 equals 0. And remember, the solution that we're talking about of this function is when y is 0. What are the values of x that'll work to make y 0? The two values that'll work are minus 1 and 3. So this function, 2x squared minus 4x plus 4, or if you want to think of it, this equation, 2x squared minus 4x plus 4 equals 0, has two solutions. The solutions are x equals minus 1 and y equals 3. So we can see that when you solve a polynomial equation, such as a linear equation or a quadratic equation, the solution or the solutions to that equation will be the place where the graph of that corresponding function crosses the x-axis. All linear equations in one variable have one solution. Quadratics in one variable can have either 0 solutions, 1 solution, or 2 solutions. Okay then, that finishes up session 89.